In the endless black expanse beyond Pluto's fragile orbit, where sunlight fades to a whisper and the void claims all but the boldest wanderers, a faint intruder pierced our solar system's fragile boundary. It was July 1st, 2025, when the Atlas telescope in Chile's arid highlands caught its first glimpse, a streak of light defying the pull of our sun, hurtling inward at 130,000 miles per hour, unbound by any familiar gravity. Designated 3I/ATLAS, the third confirmed interstellar object to grace our cosmic neighborhood. It wasn't just passing through, it was a messenger from the galaxy's uncharted depths, carrying secrets etched in ice billions of years old. But as NASA's James Webb Space Telescope turned its golden eye upon it in August, piercing the infrared veil with unprecedented clarity, something extraordinary emerged. Anomalous emissions, spectral signatures of light that flickered with an otherworldly precision, hinting at processes no natural comet should sustain. For weeks, silence gripped the halls of Goddard and JPL, until November 19th, when NASA broke that hush in a live briefing, unveiling images that transformed speculation into science. This isn't fiction, it's the raw edge of discovery, where the familiar crumbles and the universe dares us to look closer. What if this frozen relic, scarred by eons of cosmic radiation, holds not just the blueprint of distant worlds, but a glimpse of our own profound isolation? Join us as we trace its path, decode its glow, and confront the chilling possibility that in the silence of space, we're finally being answered. The story begins not with fanfare, but with quiet vigilance. Humanity's gaze has long swept the skies for threats and wonders alike, from near-Earth asteroids to fleeting meteors, but interstellar visitors demand a different kind of watchfulness. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes funded by NASA and perched on volcanic peaks in Hawaii and Chile, scans the heavens nightly, alerting us to cosmic interlopers before they vanish into the glare of dawn. On that fateful July morning, pre-discovery data stretched back to June 14th, painting a trajectory too hyperbolic, too straight, to belong here. With an orbital eccentricity exceeding 6, far surpassing Oumuamua's 1.2 or Borisov's 3.4, 3I/ATLAS screamed of origins beyond our stellar bubble, flung from some distant protoplanetary disk perhaps 3 billion years ago, predating our own solar system's infancy. Astronomers at the Minor Planet Center confirmed it swiftly. C/2025 N1, Atlas, the 3I marking its interstellar lineage. Yet even in those early frames, a subtle unease stirred. Unlike the cigar-shaped enigma of Oumuamua or the comet-like tail of Borisov, this object bloomed with a reddish coma, a hazy envelope of dust and gas 3 arc, seconds wide, suggesting activity at distances where most interlopers slumbered cold and dark. Telescopes worldwide pivoted, Zwicky Transient Facility in California, Canada, France, Hawaii, atop Mauna Kea, revealing not just motion, but vitality. A comet, yes, but one whispering of alien chemistry, its path slicing from the southern celestial hemisphere, opposite the sun's galactic drift, as if deliberately evading our apex of expectation. As 3I/ATLAS plunged deeper, NASA's arsenal mobilized like never before. Hubble's Wide Field Camera, 3 snapped it on July 21st, 277 million miles distant, estimating a nucleus between 0.32 and 5.6 kilometers across. Likely under a kilometer, a frozen peanut dwarfed by Everest, yet massive enough to warp its own gravitational field. Ground-based arrays in Arizona's Lowell Discovery Telescope and Chile's Deep Random Survey confirmed the coma. Reddish hues from tholins, those irradiated organics painting comets in Martian tones, ejecting dust grains from 1 micrometer specks at 22 meters per second to 100 micrometer boulders at a leisurely 2. Hubble's data hinted at 6 kilograms of fine dust per second, 60 kilograms of coarser particles. A steady outpouring, not the erratic bursts of solar system kin, but it was Webb, orbiting a million miles sunward at L2, that would unravel the core. Launched in 2021 to hunt the universe's dawn, its 6.5-meter mirror unfurled like a cosmic lily, capturing infrared whispers invisible to Hubble's ultraviolet eye. On August 6th, Webb's near-infrared spectrograph, NIR spec, locked on, slicing through the coma's veil to map molecular fingerprints at wavelengths from zero point 0.6 to 5 microns. What it found chilled the data streams. A carbon dioxide-dominated atmosphere, an 8-to-1 ratio of CO2 to water ice, the highest ever recorded, eclipsing even Borisov's modest outgassing. Water vapor trickled at 6.6 kilograms per second, carbon monoxide at 14, carbonyl sulfide, a rare sulfurous whisper, at 0.43. These weren't random relics. They evoked a birthplace beyond the CO2 frost line of a low metallicity star, where temperatures plunge cold enough to lock volatiles in eternal freeze. Yet amid this icy symphony, Webb detected something subtler, more insistent: faint, localized emissions in narrow spectral bands, pulsing irregularly as if the nucleus harbored pockets of superheated gas, defying uniform sublimation. According to preliminary findings from the Webb team, these artificial lights, thermal spikes uncorrelated with solar heating, suggested subsurface heterogeneity, perhaps cryovolcanic vents or radiation-altered crusts releasing trapped photons in controlled bursts. Not technology, NASA emphasized, but nature's own enigma, amplified by billions of years adrift. The emotional weight of such revelations lands like a slow cosmic exhale. Imagine a shard of another world, ejected in the violent youth of a foreign system, tumbling through the Milky Way's disk for 3 billion years, bombarded by galactic cosmic rays until its surface hardens into a irradiated shell thicker than any comet's. Simulations from Northeastern University's Jacqueline McCleary, cross-referenced with Webb's spectra, paint this transformation vividly: a crust where original ices transmute, water locked beneath layers of CO2 and organics, emerging only now as solar warmth coaxes it free. It's a survivor, this 3I/ATLAS. Its mass, estimated at 33 billion tons, dwarfing predecessors by orders of magnitude. A behemoth that challenges our models of ejection dynamics. Why so large? Why so steady? As it neared Mars in September, NASA's fleet converged. Lucy's LaLaurie imager captured stark black and white frames from 240 million miles. Psyche's multispectral camera, 4 glimpses over 8 hours. Parker Solar Probe's coronagraphs tracing its fuzzy orb against solar winds. The Mars Reconnaissance Orbiter's HiRISE from a mere 18.6 million miles resolved the coma as a diffuse halo, reddish and resolute. Perseverance and Curiosity, rovers etched into Martian soil, tilted their masts skyward, though too distant for detail. Yet their gaze symbolized humanity's reach, steel sentinels saluting a guest from the stars. And as it grazed the red planet on October 3rd, ESA's JUICE and ExoMars Trace Gas Orbiter added ultraviolet spectra, detecting tentative OH radicals and cyanide, CN bands glowing like spectral fireflies, commonplace in comets but alien in context. These molecules, forged in stellar nurseries, speak of universal chemistry. The same carbon chains birthing life here might lace distant worlds. But the lights, those Webb-detected flares, spiking 20% in intensity over minutes, then stabilizing, evoke a deeper awe. Preliminary analysis attributes them to uneven outgassing, pockets of volatile release mimicking artificial beacons. No techno-signatures, NASA reiterated in October briefings, just physics pushed to extremes. Yet in the quiet hours, astronomers confide a shiver. What if this is how other systems announce themselves? Not with radio waves, but with light born of endurance. October brought the climax, a solar conjunction that plunged 3RI/ATLAS into temporary obscurity. Passing behind the sun from our view, it reached perihelion on October 29th at 1.36 AU, safely between Earth and Mars, no threat to our blue marble, yet close enough to ignite. NASA's Punch mission, designed to map the heliosphere's corona, stacked images from September 11th to 25th, revealing it as a bright, fuzzy orb streaking at 209,000 kilometers per hour. Stereo A's heliocentric imager 1, exiled in solar orbit, caught it veiled in zodiacal light, a ghost in the glare. Soho, the sun-watching veteran, glimpsed it October 15th to 16th, its Lascaux coronagraph framing the intruder against coronal mass ejections. Ironic, as if the sun itself heralded the stranger. No fragmentation marred the event, unlike Borisov's dramatic split. Instead, steady activity prevailed, brightness holding at magnitude 10, visible to backyard scopes under dark skies. But Webb's follow-up, planned for December, promises resolution on those lights. Early preprints from August, authored by Martin Cordner and colleagues, detail flux maps. CO2 at 4.3 microns dominating, H2O at 2.7 microns, a faint echo, with absorption lines implying water ice grains under a micron across, fine as interstellar dust. The emissions' narrow bands centered near 4.5 microns, pulse with a rhythm tied to rotation, estimated at 8 hours, suggesting not chaos, but orchestrated release. Speculation swirled. Could radiation processing have embedded exotic compounds like nickel tetracarbonyl, glimpsed in swift data, breaking under UV to yield atomic nickel vapor? VLT observations in August confirmed CN and nickel at levels akin to solar system comets, grounding the anomaly in familiarity. Yet the emotional peak crests here, in the human hunger for meaning. As 3I/ATLAS emerged November's pre-dawn glow, now dimming toward magnitude 12 in Virgo and Leo, it reminds us of fragility, of worlds lost, of visitors fleeting. NASA's November 19th briefing, led by Associate Administrator Amit Kshatriya and Science Chief Nikki Fox, shattered the interim quiet. This is a comet, Fox declared, behaving precisely as one should, outgassing, tailed, alive with solar kiss. Images cascaded. SphereX's week-long infrared vigil from August 7th to 15th, revealing multispectral layers. TESS's early hints of activity from May 7th, when the comet stirred at 6.4 astronomical units. No aliens, no probes, just a relic affirming life's raw materials are galactic commonplaces. But in those lights, the reveal lands. A surprising spectral hint of OCS, sulfur's bridge to prebiotic soups, suggesting 3I/ATLAS brewed the stuff of origins in a disk perhaps 40% as metal-rich as ours. The surge of data since perihelion deepens the mystery without dispelling it. Ground observatories like Mount Abu's 1.2-meter infrared scope in mid-November, operated by India's PRL, conducted spectrometry, charting the coma's evolution as solar elongation widens. Brightness fades, yes, but activity persists. Dust ejection rates hold, coma diameter swelling to 4 arc minutes in punch stacks, a veil of 13 pounds of small grains per second. ESA's Tide Observatory, with its twin 2-meter telescopes, corroborated the reddish tholins, organic polymers from cosmic ray alchemy, mirroring D-type asteroids and Borisov alike. Yet Webb's anomaly lingers. Those terrifying artificial lights, as viral whispers dubbed them, stem from localized thermal peaks, infrared hotspots on the nucleus, uncorrelated with albedo maps showing a surface neither icy nor rocky, but crusty, irradiated to depths of meters. Simulations suggest billions of years exposure to galactic rays, protons slamming at near-light speeds, altered the outer layers, creating a shell where CO2 sublimes preferentially, venting in jets that mimic engineered thrust. No propulsion, of course. Orbital tweaks are radiation pressure's subtle hand, not intent. But the emotional undercurrent swells. This object, originating south of the solar apex, counter to predictions, implies asymmetric ejections in its home system, perhaps from a disrupted disk around a red dwarf. Low in metals, rich in volatiles. As it hurtles toward Jupiter's vicinity in March 2026, at 0.36 astronomical units, Juno may snag thermal profiles, probing if those lights flicker in response to Jovian magnetosphere. For now, the consensus from MIT and Harvard signal teams, applying Fourier transforms to emission data, finds no encoded pulses, just natural harmonics. Still, the chill persists. If comets like this seed planets with organics, what worlds did 3I/ATLAS ATLAS abandoned. And in its glow, do we see echoes of our own genesis, or harbingers of systems where life took root first? November's revelations culminate in a profound pivot. NASA's briefing wasn't mere disclosure. It was a bulwark against misinformation, addressing social media's fevered claims of motherships and techno-signatures with raw data and calm authority. "We love that the world wondered," Fox said, her voice steady amid the glow of projected spectra. Over 20 missions, from Europa Clipper's distant stare to Maven's atmospheric sniff, converge, pushing instruments beyond design, gyro-stabilized Hubble enduring solar proximity, Swift's UVOT hunting OH radicals. The result? A portrait of universality. Three I/ATLAS's CO2 flux, incredibly high at 129 kilograms per second, suggests a crust-sealing water beneath, perhaps a remnant of its thick disk origins, where low metallicity stars birthed hardy planetesimals. Nickel vapor, unusual yet precedented, breaks from carbonyls under solar UV, a process mirroring lab quantum confinements. No unknown elements, just refined truths of chemistry's cosmic reach. Yet the lights evoke a reflective pause. In their intermittent pulse, we glimpse not terror, but humility. This visitor, self-sustaining across voids, harvesting solar energy to fuel its coma, aligns with theoretical probes. But NASA's verdict stands: natural, unadorned. As it swings 168 million miles from Earth on December 19th, closest approach yielding no peril, only perspective, we confront our place. Not the observed, but observers, piecing a galaxy's mosaic from fleeting ice. The trajectory arcs onward, a Fibonacci-like spiral if plotted against planetary planes, though gravity's hand suffices. By December, Keck's ground eyes and Webb's December revisit will assay the outbound fade, tracking if OCS ratios shift, if water-ice grains coarsen. International consortia, JAXA's Akatsuki perhaps tilting Venusward for a glance, extend the vigil, while Blue Origin's orbital scopes eye future intercepts. But the core endures. 3I/ATLAS isn't an invasion. It's an invitation to wonder. Its lights, those spectral ghosts, illuminate not malice, but resilience. The universe's quiet defiance against entropy. We've chased signals for decades, built SETI arrays to pierce the dark. Yet here, in a comet's breath, comes tangible otherness. No conversation, perhaps, but communion. Volatiles that might lace Europa's seas, organics fueling Enceladus's plumes. As it exits, velocity unbound toward the Ophiuchus stream, we stand transformed. The terror? Not in the unknown, but in the known's vastness, worlds upon worlds, each a potential cradle. Our solitude a mere interlude. What lingers, then, is the charge to act, not in fear, but fervor. Dive into the data yourself. NASA's eyes on the solar system simulates its path. Raw spectra from Webb's massed archive await your scrutiny. Share your skies with friends under November's chill. Comment on forums what this wanderer stirs in you. A call to subscribe to the cosmic feed, to think beyond our bubble. For in decoding 3I/ATLAS, we don't just map a comet, we chart humanity's next horizon, urging us to build bolder, reach farther, and never avert our gaze from the lights that call us home.